Wanted to start just give an introduction to our company and our products, and then talk about how SoftPLC and the IoT View are integrated, and then some applications that are really exciting for this new technology of putting these two things together. SoftPLC was actually founded back in 1983, and we've always been an industrial software company. In 1988, we released the very first SoftPLC. So that was a long time ago. We were one of the first to create a programmable automation controller. And as things evolved, we've added to the product. We've ported it to Linux. We've added a whole lot of great functionality. And in 2013, we released a product called TagWell, which is our cloud-based platform for Internet of Things or Industry 4.0 type applications. And now in 2015, along with IoT View, we now have the IoTPAC product. So our product line includes programmable automation controllers, which is our SoftPLC, also gateways or protocol converters, so we can take data from one network to another. We also have SoftPLC Web Studio that we sell as software, but we also package it onto panel PCs and headless PCs so that we can provide HMI type products so that you don't have to do that integration yourself. We've got Windows CE, Windows Embedded, and Windows systems for that. And then we have our TagWell platform that we'll be talking about some more as we go through this presentation. So those are our four main areas of products. We do have other products, but these are our four main ones. When we look at the SoftPLC programmable automation controllers, a lot of questions that first come up is, just what is a SoftPLC? There's been a whole lot of people who use different definitions for that term. So first of all, SoftPLC is not a PLC. PLCs are, ancient technology. They're relay replacers. They're great for small ticky-tacky machines, but when you want to do something fancy, then you want a programmable automation controller. And so SoftPLC is a programmable automation controller, which means it has better communications, data handling, advanced functions that you don't find in a traditional PLC. And SoftPLC is truly open architecture. We don't provide push buttons and sensors and drives and all the other pieces that go into an automation system. And so it's very important for us to be able to communicate to hundreds and hundreds of other vendors' products. The other thing SoftPLC is not is it's not a PC-based controller. It does not run on Windows. We don't have a screen or a keyboard or a mouse. We run on very small footprint type hardware with no moving parts, no hard drives, and it runs like a controller. So it's deterministic. You can do run mode program changes. It's not a compiled program. And the maintenance people or the engineers are going to troubleshoot it like a PLC. You have forced I/O, all the same functions you're used to seeing when you go in and try and troubleshoot a PLC system. So it's a blend, and what we do is we actually take our software, which is the SoftPLC, and we put it on an industrial computer along with our Linux operating system, and we turn that computer into a controller, into a programmable automation controller. And a little bit different than a lot of the other computer-based controllers that are out there is that we've modeled our PLC after an Allen Bradley PLC. It's partly because of our history in supporting Allen Bradley PLCs with software in the past, but also 70% of the installed base in the Americas and Canada of PLCs is Allen Bradley. So there's a lot of people that understand the programming. There's a lot of built-up engineering knowledge and code base that we can take advantage of. And one of the things that we do is convert Allen Bradley PLCs to SoftPLCs by importing the logic. It's not even a conversion. It's actually an import. and then all the advanced features and open architecture can be added onto that. So it's in a very affordable way to allow customers with older technology to move forward. These are some of our hardware models. The Smart SoftPLC is probably the bulk of what most customers are using. It can span from small applications up through very large redundant systems. It's priced to compete with a small PLC like a MicroLogix or an Automation Direct PLC, but it can scale up to be larger than even a ControlLogix. We're replacing DCS systems with the Smart SoftPLC. And so what we're shown here is some different configurations of the Smart. This one here, the modules mount right on it for smaller applications. This guy in the back will connect to our I/O racks, and we can do up to 12 local racks, and through Ethernet distributed I/O we can do hundreds of racks. And then this one here without any ports on it is meant to connect to serial, Ethernet, Profibus, DeviceNet, those kind of I/O systems. And what we've shown here is that we can actually connect directly to the Allen Bradley I/O. The Hardbook SoftPLCs are our high-end models. These are used by customers who need a lot of PCI slots for add-on cards, or maybe they want a rack mount system, or maybe they need something that's really, really fast, or other reasons that people go to a Hardbook. But this one here is actually Class 1 Div 2 rated, and so we use it when we have hazardous location applications. Our micro SoftPLC, as you can see, is very, very small, very, very low cost, but it's got all the same power of our other systems, just less ports on the communication side. We use this a lot in our IoT applications, remote applications, or very, very small embedded machine controls. So if we look at the standard set of features, these would apply to all of our PLCs. These are firmware type features. The Smart actually is got a built-in Ethernet switch. All of our PLCs except the micro have multiple Ethernet ports so that the I/O and the communications can be segmented onto different subnets. And an option for our PLCs is an embedded firewall or VPN option for firmware. And this allows the system, especially if it's remote and you're worried about somebody, coming up with an Ethernet port and tapping in and doing something, gives you some security in the PLC itself, as well as in remote applications or networked applications. But if you're using something like TagWell or some other cloud application, that structure already takes care of the protection, so the firewall would be another layer if you wanted it. SoftPLC can also be a remote access switch, so you can connect in through phone, or you could put an external modem and connect in through cellular. But once you're in, you can connect to anything on that network. So you can do remote maintenance, firmware updates, look at what's going on, and also it can call out for remote alarming applications. SoftPLC can also be a data logger. Maybe you don't need to do any control, you just want to do some data acquisition and logging. We can do that. And there are a number of blocks that we have to do data logging to different formats. So we can go to CSV, you could go to a database format, or we have a binary format for high volume logging where the file is going to get very, very large, and or you're doing very high speed logging and you don't want to be doing it to a text format. And the log file can be directed to any drive. It could go to the internal flash, it could go to a network drive, it could go to the cloud, or it could go to a USB stick. So you have a lot of options on the data logging of how that's going to work. The SoftPLC can also be an alarmer, and you can do that through email or text messaging. The email also supports attachments, so you could have a report that gets attached to an email to tell someone what their production was at the end of the shift or that sort of thing. And so that is built in as well. And of course it is a controller, so it runs ladder logic, runs some function blocks, and it also runs C++. The logic is virtually unlimited. You have megabytes of memory. Our smallest controller is 63 megabytes of user memory. So you can do all kinds of things in there, especially if you're doing a lot of recipes or data handling. You've got enough memory and data table to do that. You can connect to multiple different types of I/O simultaneously. And as I said, it's open architecture, so we can talk to devices from hundreds and hundreds of vendors. And as far as communication goes, you also can configure the PLC to support multiple networks. And so you can connect to any HMI or SCADA system or GCS system via standard protocols like Modbus, Modbus TCP, DF1, other Ethernet protocols, Profibus, all those kind of things. And we also can talk peer-to-peer to other PLCs. So if you've got Modbus devices or Allen Bradley PLCs or other SoftPLCs, they can send messages back and forth. So there's a very rich set of communications as well as a rich set of I/O interfaces. So along those lines, if you don't want to do any control, you could just set this up as a protocol converter. It's a very low-cost way to be able to simultaneously send data between a lot of different networks. And there's no limit on the number of words. Like I said, you've got 100 million words of data table and up to 16 different protocols that you can communicate simultaneously. TagWell is its own product. It is a cloud platform that provides an applications interface that people can run applications in the cloud. One of the applications is a web browser interface, so that you can build web pages and do bidirectional communications to remote systems. So when we have a SoftPLC that's talking to TagWell, we call it a remote, and you can both read and write to TagWell and from TagWell to these remotes. Once the data is up in TagWell, it can be sent to browsers. It could go to Web Studio. There's a TagWell driver for Web Studio. You could go to other SCADA packages, or you could have just an application running that would send the data to an Oracle database, for example. And the remote can be a controller, so it's a system that sits out there standalone. It's controlling the application as well as communicating to the cloud. Or it could be a gateway that is communicating to other devices that are doing some of the control and then sending the data up to the cloud. As more and more vendors provide cloud-enabled devices, you could end up with a very large cell bill at, for example, an oil well, whereas if you had all those devices going in through a gateway and then one device going to the cloud, you can save a lot of money, as well as have all that data concentrated to minimize the traffic on that cellular network. So TagWell itself is the platform, but there's a loadable block or function that is free that comes with every SoftPLC that allows the communications from the SoftPLC to TagWell. The next thing we're going to talk about is a virtual HMI. So what's a virtual HMI? That means that it's a headless system. There is no monitor on the system, but it can provide HMI functionality via HTML5 to a web page. So we have two ways of doing that. One is there's an embedded web server option for SoftPLC. We actually were the first controller to support a web server. And with that web server, you can build pages. You can use any development environment and build pages that are bidirectional to read and write to the data table through any web browser. Now, we also have the option for IoT View. So in the SoftPLC, the IoT View will run and provide a more robust development environment. You have all the tools of Web Studio to do fancier displays, very easy development, and you don't need to know HTML5. You just need to know the Web Studio part of it, as well as the function of the IoT View to do the remote database interface directly. So it's another way of doing the same thing, but it's a lot easier development, and it uses more of the things that the controls engineers are used to doing. Now these pages can be viewed on any Ethernet connection, wired, wireless, or any internet connection, which could be cellular, satellite, or any way that you're going to get to the internet. So if we look at SoftPLC, it's kind of like a Swiss Army knife that provides a very rich set of functions that you can pick and choose based on what your application requires. They're all in there, they just need to be enabled. And so let's segment just down to the IoTPAC. If we look at the SoftPLC architecture internally as a block diagram, we have something called Gatecraft Linux, which is our Linux distribution that runs in every SoftPLC, and that's the base operating system. And then the SoftPLC kernel, or the SoftPLC runtime software, is the executive. It decides what tasks are going to run, how much time they're going to get, make sure everything's talking to each other and passing data back and forth. And so then we have pluggable interfaces called APIs that get the data out to the real world or to other applications. So this yellow interface is the Allen Bradley Communications Driver interface. At this level, SoftPLC looks like an Allen Bradley PLC to other programs such as an HMI, the TopDoc programming software, other Allen Bradley PLCs, or even C++ programs. So there's different Allen Bradley protocols that are supported at that interface level. Additionally, there's a TCP/IP stack in the SoftPLC which provides access to services like FTP, SSH, or NTP for Network Time Protocol time syncing. So through the FTP and SSH servers, from the network, you have access to the SoftPLC flash, so you can do remote updates of files, access reports or text files or log files that the SoftPLC may generate, firmware updates, update the web pages that are embedded into it, and that sort of thing. Down here at this level is our C++ interface. We have a toolkit that provides this technical detail to people who want to write their own C code to run in the SoftPLC or to access SoftPLC via C programs. And this can be used for device drivers, which could be any kind of I/O or devices, USB I/O, serial I/O, any of the standard protocols that are used in industry, that sort of thing. Serial protocols, Ethernet protocols. You can also use this interface for custom instructions. So I've talked about a few of the instructions that we have, like data logging and email and TagWell, but there are literally hundreds of others, and a lot of customers create their own just because it's a very nice way to protect your proprietary technology or to make the system truly efficient. For example, we had one customer that did Fourier transform functions. You'd never want to do that in Ladder Logic, so he wrote some C code to do that. We also have our web server down here, which allows a web browser to view the pages and get the data table information embedded in those web pages. And then the last piece we're adding here now is the IoT View. So the IoT View runs within the Linux environment, and it talks to SoftPLC through a driver at this interface level here, and has full access to the data table of the SoftPLC, just like if it was running on a Windows box and talking to the SoftPLC over Ethernet. The IoT View also, through other drivers, have access to, for example, Modbus TCP through this layer to talk to I/O or other equipment that might be on that network. And then the IoT View is going to generate the HTML5 pages, which can be viewed in a browser. So as we look at the kind of solutions that are out there for automation, we have the traditional PLC HMI combination. This has been around since the 80s, where we have, whatever controller you want and whatever HMI you want connected by some kind of communications protocol. Then a couple years ago, actually more than a couple years ago, there's been a whole host of products that have rolled out that are combined PLC and HMI. These tend to be lower cost, lower functionality type products, just because their target market is simpler applications where you don't need a lot of I/O and you don't need a lot of SCADA type functionality. You just need an HMI. And now we have the IoTPAC, which is the controller with the embedded Headless Virtual HMI. And this table is just my way of, I guess, kind of say, okay, here's my application, what do I want to choose? And it's going to depend very much on the application and what you need. But as you can see, you can save money, save maintenance costs, reduce the size of your cabinet, reduce the energy use of the total system by getting rid of that screen. And then now I'm going to talk about some other applications and reasons why you'd want to use the virtual HMI. But, it's not a great solution if the operator needs to stand there and look at the screen all day, or he needs to constantly, be touching the screen to do things. But it's a great application where you don't need that constant interaction. One other thing I want to mention here is you can have the HMI running in the PLC and access it through a wireless or Bluetooth or hardwired connection. But if the remotes are connected to TagWell, you can actually put IoT View in the cloud as well. And there's a TagWell driver from IoT View, which would allow this instance of IoT View to access any one of these remotes. So it gives you a great low-cost, cloud-based access method for a whole lot of remote systems. This is an example of one of our customers' installations. This is the Microsoft PLC, and it's mounted on an I/O board here that has some relay outputs, some digital inputs. This particular board also has a solar power battery monitoring circuit. So if you've got a remote system that's powered by a solar panel, you can have the PLC provide warnings and alarms when the batteries are not functioning properly or there hasn't been enough sunlight or whatever. We also have here a modem, a cell modem, so that we can get to the cloud. So this whole system, without the solar panel itself, is less than $800. So it's a very low-cost way to have a very powerful system that is bidirectional, cloud-based access, data logging, control, HMI, everything. So now I want to talk about some other applications of where this IoTPAC concept might come in. It is called Internet of Things, but there are also applications that have nothing to do with the cloud where this makes sense. So maybe we have a bunch of machines in a plant that we start them up, we load the recipe, and then it just runs on its own for days. Maybe it's a little process that needs, like an oven that's going to do a heat treating cycle, or just a small machine that just kind of clicks away and nobody needs to touch it. So why have the HMI there? It adds cost, it adds complexity. So someone could just come by with a tablet or a laptop access the IoT View screens, do what they need to do, and then disconnect and go on to the next one. So this is a nice solution, like I said, for certain types of machines. Some systems, especially OEMs, you just can't compete if you're going to put a nice fancy panel PC on the system. Again, if you don't need that all the time, you only need it periodically, take it off, put in the IoT View, and let someone use their phone or their tablet to access the screens when they need to. This is another example. We obviously don't need an HMI up flying around on a drone. So here we can put in like a Bluetooth connection or something like that and look at what's going on while it's flying around. So we don't need to have the HMI on the system in those kind of applications. Another good example is vehicle-mounted systems. HMIs that get put onto these type systems tend to be very, very expensive. High vibration, drastic temperature changes, bumps and rattles and that sort of thing. So the IoTPAC makes a lot of sense here because, again, when it stops and you're ready to look at things, you just pull out your tablet and you're ready to go. This particular system here is one of our customers. They do remediation where they're cleaning up a oil spill or something like that, and they were constantly having the HMI break or die because of the temperature. And so the IoT View, they're in the process of retrofitting their systems now to use the Headless Virtual HMI. Remote systems is one of the key uses that we see for this. Again, nobody's there. Why have an HMI sitting there? Whether it's a hazardous area or it's hot or cold or whatever, you've got a lot of cost in a high-end HMI to live in that environment. And so by eliminating that, you can reduce maintenance, reduce cost, and all those sort of things. You still got all the functionality. The PLC can do the logging. The IoT View could do remote logging to a remote database in the cloud. So you're not losing anything by eliminating the screen. Some other remote system examples. This is a pump station. The SoftPLC is sending the data to TagWell. And then we've got a SCADA system that's grabbing it off the other end. So the HMI, when there's a problem, the guy can show up and plug in his laptop and pull up the IoT View screen for his detailed troubleshooting. Here's some other remote systems, just examples. I'm out in the cornfield or whatever those, I guess soybeans or whatever those are. I've got a weather station here. For example, we did one system that was monitoring the river levels feeding into a dam. There's nobody out there. It's out in the middle of nowhere. So we don't need an HMI, but we need that functionality if something's wrong and we need to go look at it. Submarines, another good example here where we don't need to have the HMI all the time. So what I'd like to do now is just kind of show you a live demo of a system. I've got a Microsoft PLC here in the office that is running the SoftPLC and the IoT View, and it's also doing some data logging. So let me get out of here. And so this is the PLC Ladder Logic. Those of you that know Allen Bradley PLCs can see that it looks very much like Allen Bradley PLC. I'm going to go to this program, and down here, what we're saying is when the tank level is low, we're going to send an email, and so that's what this little subroutine does. I'm going to Let's shrink this down a minute. Look at that. And now I'm going to load my browser. And log into the IoT View. Get rid of that. And so here's the IoT View login screen and just some of the functions that we can do. I'm going to go to this screen here and a tag monitor. And this particular one, when the tank is low, I can request the truck to come. And it's going to send out a request, and then a little bit later you'll see the truck come and it'll fill up the tank. So while that's happening, we're going to go to this other screen and look at a well monitoring screen. And you can see it's a standard Web Studio type screen. You can see the values here reflected over here in the top dock in the PLC. So you can see that the data is transferring between the two applications in the PLC. I just had a fault here. We have alarms. You can see the drive faulted. I can Here it is. I'm going to acknowledge this alarm. I can enter a comment. And you can see that the alarm has cleared now. I can do trending. And you can see here the values here are going to reflect over here. And we have our standard Web Studio type trend functions available in the IoT View. Let me see if my, nope, not yet. Okay. I go back to our screen, and we filled the tank, and now it's getting lower again. And we should be getting an email any minute now. There we go. So the PLC sent the email to tell us that we had this alarm because of the condition that we had set on that rung that we looked at earlier. Right here. So as you can see, we've got that very little box, if you remember what that micro looked like, doing all of these functions. Let's look at the log file real quick here. That's the other thing I wanted to do. I'm going to just go into the actual SoftPLC itself just to show you. We're generating this CSV file from the SoftPLC to the flash disk in the SoftPLC. And if I wanted to look at it here, you can see the data, but that's not what people would normally want to do. So instead, what you could do is, let's say we do a FTP transfer. Let's log into the PLC. We want to go home, log, and there's that file, and we can view it here. And you can see that that data was sent to the CSV file that we can look at it with Excel. It's an extremely powerful set of tools here. And here's some contact information. If you guys have any other questions, feel free to contact us or go to our website, take a look at the products. We've got downloadable demos of both our programming software for the PLC as well as the Web Studio.